Okay, good morning. I'm Jim Carefoot from Armada, and we are here to talk a little bit this morning about the TDR. And welcome to those that are here. We'll be recording this and putting it on our YouTube site so that it's available for those folks that couldn't be here. We decided to do this just ahead of the holidays. I know a lot of people are traveling and on business and holidays themselves, so we are just decided we would do this partly because we could record it and make it available for everyone. So we've had a lot of requests for information on TDRs, and I know Craig Reed has done a couple of webinars in the East, and we are going to do this one to make it more generally available because folks are getting more and more interested in this as a tool. But it's kind of a mystery, so that's one of the reasons we're doing it. You may be able to see me as an inset here. I'm going to kill that when we get started. It's not pertinent to the program, of course, so I'm going to be shutting that off. And you should be able to see my slideshow. We're basing it mostly on the slideshow, and I have a little second camera to show the face of the actual unit that I'll do some button pushing on as kind of a help. But since it's being recorded this way, we're kind of going heavy on the slideshow. So I'm shutting myself off, and we are going to get going on this. All right, what we're going to try to do today is take a little bit of time to see how the TDR works. That kind of stuff always helps with test equipment. If you kind of understand the underlying principles, you can troubleshoot for yourself a little bit better, or if you run into an obstacle. Knowing how it works is helpful. Learning the kinds of things it can be used for, both in our experience in telecom and irrigation, the kind of problems that can be solved with it, and both from what we hear from customers and from theory. Some specific techniques that can be used, since it takes a little bit of experience and skill to make this thing work properly. We're going to touch on some of those things, and along those lines we are going to try to talk a little bit about the limitations of the TDR, for example in distance and for the kind of faults you can see and how far you can see in certain systems. So we'll touch on all of those things. What's the TDR useful for in irrigation? We've sold a lot of these TDRs into cable television and telephones type systems where they are used to do many of the same kinds of things, but it hasn't been all that useful in irrigation until relatively recently. One of the reasons is that you really need to be working with multi-pair jacketed cables or two-wire cables, control cables known as MAXI or ID1, that are very much like telephone and communications cables. So as a result, the TDR works very nicely on these systems. The main purpose of the TDR is to measure distances along cable sections, and that has some really useful things, as you'll see about it, things that are good to be able to do. It lets you spot things along the cable path or at the end of the cable path, like splices, decoders that may be out there, short circuits, even cable damage of different kinds. These are things you haven't been able to do before, and you have to learn to recognize a few of these things. We've got buried cables, and buried cables are always a mystery to begin with. We have to go and find the path of the cable first, in this case, and then we can look down the cable with the electronic gadget and see things. Some of these wiring glitches we can see with a TDR are ones that we don't find with locators primarily, although we are working on the Pro400 and doing some more application testing that might help with two-wire systems. The Pro400 has some nice features that may help a little bit more. The other thing about the TDR is it shows you how far it is down the wire to something, whether it's the end of the wire or damage, but you can see the nature of the damage or the fault. You can tell if it's an open circuit or a short circuit. Even if you can't see the distance, those are useful things to know. We have one guy that we work with who even uses this on open wire, just the lumped cables or wires laying in the bottom of a trench, which is really common in multi-wire irrigation systems. He doesn't care about the distance. What he cares about is the order of the wires, whether zone 1, 2, 3, 4 are the farthest, closest, and he orders them in that way, and he can see if there's damage, and he doesn't care how far it is. But most people are going to be interested in distance, and these things are particularly useful in irrigation. Most of the attention we get with this thing is if people have lost valve boxes. In two-wire irrigation systems, the electronic decoders that are used to trigger the valves hide the solenoid in the valves, and as a result, you can't typically find the solenoid the way you used to in a regular irrigation system, where you were tracking the cable outbound, and all of a sudden you get a really strong bloom signal that you're right over the box. So if the box is hidden, you can still find it. Not so in two-wire systems. So this is a technique that you can use to help find those things. When there's a cable fault and you want to know what kind it is, you've got a trouble down there, you've got maybe a short circuit, you've got overcurrent showing at the controller or something, you want to know, is it a short circuit, is it a cut cable, what is it that's happening out there? Another one that's kind of interesting that I run into periodically, you want to know if a cable goes anywhere. Sometimes you're at the head of a cable, you don't know if it's cut 10 feet down or 5 feet from you, or whether there's anything there. And that little photo I have on the inset shows a Rainbird controller at a local golf course here that had been hit by a vehicle and knocked over and been stripped of equipment, and the cable stubs were sticking out of the ground. So I was able to use the TDR, go over at the thing, notice that it was a Maxi 1 cable or Maxi cable, and connect to it, and I was able to see that the cable actually still existed for about 220 feet down along the golf course, and was cut off at the end and laying in the dirt. These kinds of things I could see both between the electrical meter and my TDR, was able to tell what was going on there. Makes a good practice. You want to know how much cable is left on a spool. This is a particularly useful thing in telecom and in irrigation. You've got a spool that has a certain amount of cable on it, and you used a chunk and you don't know how much is left. You don't want to go out on a 500-foot project and discover you have 300 feet of cable left on the spool. That's something you can do with the TDR as well. The thing we're going to talk about today is the Armada Pro400. The fault finder, we call it, or TDR. I sometimes call it a wire radar because that's pretty descriptive of what it does as far as I'm concerned. Things that are important to us in this application, of course, are a locator. We have to know the path of the cable, or we can't really do some of this measurement that we do is not very useful. Secondly, because we're working in feet and distances on the cable, a distance wheel is an important tool that we add when we're doing two-wire and other kinds of troubleshooting, where we might have an idea that an issue is some number of feet, like 65 feet down the cable. You can wheel it off and you'll know you're in the vicinity. So these things kind of all work as a suite, and this is what we typically demonstrate. The TDR, or Time Domain Reflectometer, as it's known in the telecom business, is really a wire radar, and I hate to even use TDR sometimes if people don't know what it means. Most of our customers, of course, are water and turf people and not electronic guys. What I'm illustrating here is connection of that Pro400 to a cable situation of some kind. The cable starts out at the end that you're working at. It may go through a splice, through another piece of cable, to a valve box where a decoder is installed, and then on to another valve box where it may end. What we're doing here, what the Pro400 is doing to help us out, is sending a pulse down the wire. Not a big one, nothing like a GFL 3000 or something. It's just like a 5-volt type pulse going down, and it's going back into a listening mode for echoes that occur down the cable from events down the cable. And those events, in this case, are even a splice, a place where something has been attached like a decoder, a place where the cable is cut or shorted, produce echoes that come back to us and are shown on the graphical screen of the Pro400. This is a graphical TDR, meaning that it's showing you actual measurements that it made on the line graphically. There are some TDRs out there, you connect to this cable and it will tell you how far away it thinks the end of the cable is in feet, a numerical value. Now there's some people who like to use that. I kind of prefer the graphical TDR because I can interpret it for myself, and that is what ends up happening when you're doing troubleshooting, is you're doing a lot of interpretation based on your experience. In this case, you can see we get a little echo that comes back to us on the screen from a splice. We get a bigger echo coming back from a place where a decoder spliced in, and then we get another echo from where the end of the cable is. And if you look at this, it wiggles on the screen. You can kind of you just hook up to the cable and you can say, oh, okay, I know what I'm looking at down there. You know, in the case of this little inset display, I know about 50 feet away the cable is open. So it's been cut, or it's open or unterminated at the other end. I'd also know that some 30 feet along or so there is a splice, and it's a good splice because the signal is going past it and I'm getting that kind of an echo. So all kinds of information that we can get. One of the key skills here is to recognize what these wiggles and echoes mean that are coming down the line. If you just hook to a line that's open on one end, you'll just see an upward blip. You know, something fairly clean in the trace, and you'll see a big upward blip. If the line is shorted, you'll see a downward blip. These are things you can try. Hook it up to a piece of wire, And it doesn't have to be very long, actually. You can see examples of how these things work. And I'm going to show you in a second what it looks like on my test unit that I've got here that has a splice and has a decoder on it. Something that's very important for our people that are working on 2-wire is, what does a decoder look like? And a decoder looks a little bit like a splice, except it soaks up a whole bunch of energy and you see a big downward swing. I have a little Hunter decoder attached to my cable here in the office that I'm going to show you so you can recognize what it sort of looks like. If there is a place where the line has a junction and it shoots off in one direction and keeps going toward two different valve boxes, you'll see what looks like kind of a bridge or a T, and that is typically a downward spike that looks like a short, followed by an upward spike where the end of the side run is. That is a little harder to see, a little more difficult, but this is the kind of stuff that you need to learn. And in fact, we have some application information that helps people remember these things. What we'll probably eventually do is put a little cheat card on the back of the Pro400 that's good for irrigation. The Pro400 now comes with a cheat card on the back that's mostly oriented to telecom. So as usual with these things, this one takes a little bit more. Even with locators, we always say locators are half art, half science. People that are experienced with locators can really make them work. And they recognize problems, they recognize application issues and cable faults. That's very much true with the TDR. It's still the bloodhound's brain, and you are the bloodhound. Test equipment is just your nose. You've got to use it to help you find things. So it becomes experience-oriented just like it does with a locator. You just want to give people a little bit of a get-started thing before they really get into the field and try it on some cables. One of the things you need to do is, and I've got a little display there that shows the menu setup. One of the first things you do when you get one of these units is do the menu setup, and then you don't touch it very much after that. But I'll step through that just briefly as well. The most important thing, there's two steps to this thing, is establishing a working VP. And VP is the techie word that we use for the cable correction factor. It's also known as velocity of propagation, and it's expressed in a percentage of the speed of light. So that's why I never talk about it very much. VP is velocity of propagation. I just as soon call it a cable correction factor, because that's the factor we use to make our distances work out. And you can pick that from the table. I'll show you an example of the table here in just a sec. In one of our application notes on the Pro400 has a table that shows you different kinds of cables and wires and what the correction factor is to make the distances come out right. The best thing to do is to actually take a piece of working cable that in the system you're working with, you may know a distance maybe to the first valve box, shoot it with the TDR, see what the cable is, and adjust the cable correction factor till the distance is right. And many of the distances after that will be okay as you move around the system. We always say, get a good working VP. The best way to do it is use a piece of working cable from the system you're working on. And that can vary quite a bit. You can shoot a cable on a spool, that's fine, but it varies when the cable's stretched out versus being on a spool. Anyway, and ultimately you shoot the cable. And when I say that, you mean you initiate a TDR pulse, and it comes back and tells you what it sees. If you don't see much, or if the range isn't right, you can step the outside boundary of the display out and in until you're looking at the right distance. Normally I start out with something like 100 feet or some such a thing, and then see if I get any echoes. If I don't, I start moving the range out. This current model of the TDR has a gain adjustment, which means if you can see some little wiggles out there, but they're hard, they're just little wiggles, you can step up the gain and get a better pulse picture. That's especially useful when you've got little wiggles beyond the first valve box. You want to see what's going on out there, you can step up the gain. So anyway, we're going to go through this little TDR setup thing, but people don't have to do much once they've done it. What you very often have to do is adjust the VP. And this little setup screen here shows that I've set a VP of 67%. That's the correction factor for the piece of test wire that I happen to have here in the lab. So this is the cable correction factor. It's in the app note. It's also in some of our slideshows on 2-wire. Gives you a little bit of an idea. In irrigation, we go right down to the bottom of the cable. If you're in 2-wire systems, you're typically using either an ID1 decoder cable like Hunter provides, or you're using a maxi type from Page that's used in everything from Rainbird to 2-core systems. So we're dealing kind of with two kinds of two-wire systems, and you can see the correction factor varies. What I find is when I stretch the cable out on the ground with Hunter cable, I use a correction factor of 73. Literally, when I go down to buried cable that's actually in service, the correction factor is way down at 57. So you can use this table to get started on, but as I say, the best thing to do is to actually measure a piece of cable in dirt. So to be successful, if we care about distance, which most of our customers do, we are going to try to get an accurate VP correction factor. And things to be aware of is that the cable on a spool actually looks 3% longer than it is when you stretch it out. So be careful about measuring a cable. I think it's always a good idea to take a known length of cable, like a 250-foot spool of two-wire cable, and shoot it and see what the correction factor is. Just be aware when you stretch it out, it's going to look a little bit shorter, and the distance will be off by that much. So always, it's useful to shoot when you're checking on cables, whether how much you've got left. But when you're actually working on cable in the field, you want to be aware that the value drops. Once you bury that cable, it's going to drop quite a bit more. So if you're out there using Hunter ID1 cable and you're trying to figure out how far it is to the first valve box, set the correction factor in the TDR to 0.57 to start out with, and then you can adjust it when you actually move on. So just a sec here. I'm going to have left the audio open, so excuse me a second here. I'm just going to mute everyone for the moment. All right, so the best thing always is to experiment with known cabling. Shoot a distance that you know for buried cable and use the VP correction factor. That's the critical thing. Wheel it off. If you're up at the head of the controller, disconnect the cable from the controller, attach the TDR to it, and shoot down the cable and adjust the range so you see the first kind of a blip and you say, oh, okay, there's a splice. That's probably or a decoder. That's where the first valve box is from here, and it reads what the distance, and then so you take your distance wheel and walk down the cable path, and you should be right on top of the valve box when you get down there. If you're not, or you can see the valve box, tweak the cable at the adjustment or VP correction factor a little bit until the distance comes out right. And from the rest of the project, as you work through that system, you'll be able to rely much more on the actual distances. As I said, you can look down the cable and see what it is that's down there. It's a splice, it's another valve box, it's a decoder, it's a cut. Very useful kind of a gadget for finding cuts, although usually if we're looking for cut cable, if we have a ground fault locator, that's the quickest and most accurate way. But this can also do that. So know the limitations when you shoot down the cable. Stick to things that are fairly close into you. By that I mean when you are looking down the cable and you see the first decoder, that's great. The first decoder, though, is going to suck up a lot of signal from the TDR's pulse. That means that subsequent boxes downstream are going to have smaller and smaller signals that are difficult to see. So there is a kind of a range limitation, especially with decoders, because they soak up so much energy. But this little inset that I've got here that shows, and the blip on the left that stands up in the air is you. That's the beginning of the trace. So what I've done here is shot down a cable. It was Hunter cable that I'd laid out, and there was a decoder up at the end of it, and it was 100 feet away. I could see that there was a decoder, and it's sucking up a lot of energy. If there was another decoder another 100 feet down, you'd be able to see a little wiggle out there. You can step up the gain and measure the distance to that second decoder also. But it has a limitation to only run the first decoder or a few decoders. So the little wiggle before you get to the decoder is a splice. My test cable had a splice in it. It was just a good splice, but it was there, just wire nuts, and then there was a decoder at the end of the cable, and that's what it looks like. So pretty good example of what you'll see when you're in a real system and shoot down. What I'm going to do now, if you bear with me for a minute, is switch over to my second camera and show you the face of the unit. There are a number of button pushes that have to go on to operate this thing, and obviously when you're using it, you get used to it pretty quickly, and it's not too hard to operate the thing. There's a power button. The really important things on the front of the machine are the little symbols that are next to the buttons, less the words and more the symbols. So you push the power to turn it on, and then you can push the down arrow to cause the thing to run a trace. I'm going to switch over to my camera here in just a moment. Okay. Hopefully now everybody can see. I've got a bit of a Pro400 working Pro400 set up here on my desk, and I've got it hooked to a piece about 50 feet of cable. And so what I'm going to do to begin with is, of course, turn the unit on, and we get this splash screen that has the company name and some options. If you just immediately push this button, it'll start a scan and run the scan downstream and tell you what's going on. You can use this menu. I don't use this menu too much. What I do is I like to go put these two together, and it brings up this wordy menu, which I prefer over the graphical menu. So this is what I'm illustrating here. You can see that what I've got on the screen is now it's waiting for me to tell it what I want to do, and I have selected this unit to be a TDR. I can switch it over and it can be a tone tracer, which is another useful thing sometimes to do is you can then use a tone probe to trace, just like any of our gadgets that generate tracing tone. You can set this one to do that. In this case, we're just talking about the TDR. So as I step down the menu using the down key, I can choose to set the correction factor in a different format. Right now I'm using a percent VC, which is the speed of light, so hard to explain to people. But the VP, or correction factor, right now is set for 67%. That's what it's pointing to. In order for me to change that, I just push the plus and minus arrows, and I can make it a lot smaller or larger. If this distance setting wasn't working very well for me, I might get out there, wheel it off, and then change the VP until the distance was coming out correctly. So you can set for 2-wire cables. I typically use a main 25 ohm setting. I'm using feet instead of meters, that kind of thing. So once I've set this up, and typically what I've done is just set the correction factor to get going, and then I'm back to the screen, and either the down arrow or this, you'll see it says TDR on the bottom corner of the screen right here. So when I push this key, it runs a trace. So there it has given me a graphical look at what's happening down the cable for me, and it is showing at 50 feet there's a decoder, and in between you can see, or somewhere around 20 or 30 feet, there's a splice. That actually is just a place where I skin the insulation off and spread the wires out a little bit. The TDR is so sensitive that it can tell if there's something going on between you and the next valve box, like even just a splice. So there's the decoder, a little bit of an upward blip and a big downward, and it's at the end of the cable. If I'm going to release the decoder here, and what I should illustrate, what I'm going to do is the down arrow, if I hold it down for a minute, I put it into, you'll see a little symbol appear down in the corner. That's the continuous retracing mode. So it's shooting the cable constantly without my pushing the button. Now, this is good to leave it in here if you're going to change something downstream and you want to see it change. So like here, I'm going to release the decoder. Well, there you see it, nothing but an open circuit. So if that decoder was disconnected, you can see that big upward blip again. I can see that I've got an open circuit at 50 feet. So now I want to kind of wheel it off and go down there and see what happened. Is the wire nut come off the decoder or something similar? So when you'll see that what I've got here is this thing set for the 90-foot range. If I thought, which is fine because I'm working in distances like 50 feet, you might be working a couple hundred feet down to the first decoder or first valve box. So you can adjust the range by holding the range key down, and I push the up or plus key a few times, and now I'm looking at 360 feet worth of cable space out there. Now there's nothing out there, so you can see that, but you can see way back here is the cable that I was working with. So I'm going to actually, oops, get back here, change range and go minus, and move it back into the range that I want to see. So there I am looking at my cable again. If I wanted to see something in a little bit more detail, I can hit this select or range key right here. I can step up the gain so I can see little wiggles. That helps especially if you're looking past a decoder, but I think generally I just take the default. You see dB equals default. So I'm back to my screen. So you can step up the gain. That's great for seeing details. You can step the range in and out so you can see what's coming down the cable next. So this thing has a backlight. This key down here in this corner is useful. You can, if you need to, depending on conditions, you can turn on the backlight. So once you get it set up, relatively straightforward. We have a manual for it. Of course, I have an updated manual that is, I think, is better than the one that's in the box. So that is also available. Created our own little Word document that goes into some more descriptive stuff applied to irrigation. That's available. Also, the data sheet or the application note. We'll switch back here. Okay, so there are a bunch of keys and they're a little cryptic when you first see these things, but they get pretty familiar as you use them. So we're again looking at a graphical TDR. It's showing us a display of what it sees down the cable in the forms of echoes and blips. Key information appears, of course, in that one center area. The stuff that's above and below it has to do with settings, although the distance reads out on the lower left. And this is a very great thing, actually. If you're pretty confident or even near with the cable correction factor, you can tell how far away you are from and what kind of an event it is. The one on the lower left there shows a short circuit of 50 feet, a very big downward blip. You can still see the splice between here and there, but it shows you that the end of the cable is shorted at 50 feet. And to the right, there's another little example of a cable that's open at 50 feet with a splice, or at 100 feet with a splice visible at 75. You get used to looking at these. You try them in some real systems. They're very useful devices, the TDRs. Once again, the cable correction factor has to be set for you to get the best value out of it. Here are a couple of quick examples. A clean cable out to 1,500 feet, you won't see much of anything. If you look down a piece of 2-wire cable or a piece of coaxial cable and you send the pulse down, it'll be nice and flat unless something happens to it. At the end of the cable, you would see an upward blip showing where the end of the cable was, and you could measure the distance to it. This is the situation where you might be measuring a spool of cable. The next one down shows 2 splices followed by an open. I had decoder cable set up. It was I think it was ID1 cable, Rainbird cable set up with 2 splices in it where I was attaching and removing decoders to see what they looked like. And this is what the cable looked like. I could see I had splices at a couple of different distances. I could measure accurately to them. And the big upward blip is the end of the cable, which is wide open. So here's an example of what you might have is when people pick one of these up and they hook it up to a system, they're going to look and see what looks just like a jumble of pulses and echoes and that sort of thing. You have to know a little bit about what you're looking at. Don't try to look too far down the road, because in some of these cables you'll have echoes bouncing back and forth. This situation, I've got a cable at that's only 44 feet long, but it has a decoder attached to it and there's a splice. This is actually one of those cables I showed earlier. You can see the good splice on the left. That's there, but at what was the second splice, I've now attached the decoder. You can see a little upward blip and a big downward swing. That's a sign there's a decoder. If I move my cursor in there, I think that was about 30 feet. It would show me there's a decoder 30 feet away. And the cable was shorted at the far end. So the short doesn't affect our ability to see up to the short, so that's a great thing. So at 44 feet, there's a shorted cable. Stuff to the right, you'll learn to ignore some of the stuff that you know is way beyond where you're really interested in looking. So people will sometimes see this, and it looks a little bit like a jumble, but a little experience will help you understand what you're looking at. We'll be putting this little webinar up. I'm going to show you also a moment here to switch over. What we have done is produce some of the same information in the form of an application note. There it is, I think, on your screen now. And in there is this table we talked about for getting the VP right, some examples of what screens look like, the equipment, which keys you push to increase the range, increase the gain. These are just kind of a quick start guide for someone who picks up one of these things that just needs to get it into the right mode and get a starting point. This application note I'll be putting up on the website and will be available for download. So, I'm switching back here again to my slideshow. So we have a ton of these of demo and training videos that are up there, and this will be added to that. One of the things that we'll be adding to it will here are some of our various web addresses. All our training videos you can reach either through our main website or through our YouTube channel, which is Armada Tech. Something we'll be adding in the future is a little more detail on the two-wire troubleshooting. This is sort of related to the TDR because people often use the clamp meters and TDR together to try to sort out how far it is between boxes and what faults they might be dealing with. So there's a lot of interest, obviously, in two-wire stuff. So we'll be adding another webinar just downstream from here in the early part of the year to help with that. So that having been said, I'm going to see if I can unmute, but it's not letting me unmute all. Okay, anyway, that's our webinar for today, and we just wanted to touch on the application of the TDR so that you understand sort of what we're looking at, introduce the fact that we have an application note that helps with getting started, and I thank you all for attending, and we'll be talking to you down the road. I'm Jim Kerfoot with Armada.